Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from Group 8. We will explain about virtual memory. First, I will introduce myself and introduce my member. Um, First, there is myself. My name is Muhammad Rizky Raihan Firdaus and my friend Ashifa Nur Maulidia. Next, Muhammad Ryan Gifari. Next, Muhammad Ryan Saleh. And the last one, Muhammad Fajar Mutakin.
Hello, my name is Ashifa Nurmalidia. Now I want to explain about virtual memory. The definition of virtual memory is a technique in the operating system that separates logic memory from physical memory, or increase the memory available to the program. Logic memory here is the entire pages of a program. Well, without this virtual memory, all logic memory will be directly taken to main memory. Well, with this virtual memory can be used for separation that brings this logic memory to the second storage or hard disk and only brings the required pages to physical memory. Virtual memory allocation taken from hard disk. The purpose if RAM overload then swapped to virtual memory. In here, the pages of virtual memory are labeled page 0, page 1, page 2, and page N. Each page has the same size. For example, 4 kilobyte. The physical memory cylinder is divided into frames that also have the same size as pages. Each frame can hold 1 pages of virtual memory. In this picture, in here, we can see that there are some pages that are in physical memory, such as page 0, page 1, and page 2. There are also some pages that are not in physical memory, such as page N. This shows that virtual memory is larger than physical memory. That's it for me.
When is virtual memory used? Virtual memory in an operating system is used when the physical memory or RAM is not enough to hold all the data needed by the running program. Virtual memory utilizes part of the hard disk space as additional memory, which is called swap space or paging file. Thus, virtual memory can increase the memory capacity available to the program and allow the program to use memory address that are larger than the physical memory size. Virtual memory management strategy. First, page mapping. Page mapping uses mapping technique to associate global logical arrays with physical arrays in physical memory. This allows the operating system to access page data efficiently. Next, page replacement. If all physical memory pages are full, the operating system must replace a page with a new page. Some commonly used page replacement algorithms are LRU, less rationally used, default, first in, first out, and optimal. Next, swapping. Swapping is a technique where part of program or entire program are moved out of physical memory to disk when not in use to make more room for other running applications. The difference between the three. Page mapping. The page mapping maps the logical address in a program to physical memory RAM with the help of the page table in the memory management unit. Page replacement. Page replacement that moves some page in physical memory to virtual memory and replace them with the new page needed. Swapping. Swapping is a technique where part of program or entire program are moved out of physical memory to disk when not in use to make more room for other running applications.
Okay. Next, I will explain demand paging. So in the demand paging scheme, what will happen is that we will have a secondary storage device such as hard disk. Then there will be a certain space allocated as swap space. Here are the executive blocks be available. For example, if a process will has block 1, block 2, block 3, block 4, block 5, and block 6. And all those blocks will be in swap space, and it only depends on the system request to block the process blocks load from swap space. Then what is swap space? Swap space is a secondary storage space used by the operating system to store pages that are not in RAM. Swap space is represented by a cylinder with a number inside, which represent the page that has been swapped out. The size of swap space is larger than RAM, so it can accommodate more pages. Process page table in RAM is a table used by the operating system to record information about each process page. The process page table in RAM is represented by a table with 3 columns: block, page frame, and P or D column. The block column shows the logical page number. The page frame column shows the physical frame number, and the P or D column shows the physical shows the whether the page is in RAM or not. The demand paging scheme works in the following way. When the CPU wants to access a page, the CPU will look for the page in the process page table in RAM. If the page found and the P or D column is number 1, it means the page is in RAM and the CPU can access it. If the page is not found or the P or D column in number 0, it means the page is not in RAM and the CPU will experience a page fault. Page fault is a condition where the CPU cannot access the required page. When a page fault occurs, the operating system will perform the following steps. The operating system will look for the request page in swap space and move it to RAM. If RAM is full, the operating system will choose one of the pages in RAM or to be swapped out into swap space using certain algorithm. For example, FIVO, first in, first out, LRU, or OPT. The operating system will be update the process page table in RAM by changing the page frame and P or D column values according to the new conditions. The operating system will repeat page search in the process page table in RAM and send it to the CPU to continue the execution. Okay, next, I will tell you about the advantage of virtual memory. First advantage is allow the program to use more memory than is physically available. And second, allows programs to use large and uniform memory addresses. Third, allows program to share data easily using the same memory address. Fourth, allow programs to run without having to be relocated using a relative memory address. And fifth, reduce physical memory usage by moving regularly use memory page to secondary memory, thereby increasing memory use efficiency.
Where is virtual memory implement? Virtual memory is implemented in modern operating system using the technique of mapping logical memory address to physical memory address. A logical memory address are the address used by program Well, physical memory address correspond to actual location in my main memory RAM or secondary memory hard disk. The mapping of logical memory address to physical memory address is performed by the memory management unit MMU, which in component of the processor. The MMU used a data structure child pega tables to store information about the address mapping. Example of operating system that use virtual memory include Windows, Linux, Mac OS, and Android. Example of program that use virtual memory are web browser, graphic application, multimedia application, and programming application. Virtual memory allows the test programs to run efficiently and securely in the operating system. In in the scenario, virtual memory can be used to store temporarily inactive data on the hard disk, allowing application to continue running even with limited physical memory. An efficient implementation of virtual memory can en- en- enhance to overall system performance.
Alright, this time I will explain about how virtual memory works. In this picture, there are two cases. The left one is an operating system without virtual memory and the right one is operating system virtual memory. I will explain the left part first, where an operating system without virtual memory has a rule that program address equal memory address. Now here is a program that needs 4 GB or memory while the device we have in only 1 GB. How does this work? Let's see. Program 0 is mapped to memory address 0. Program 1 is mapped to memory address 1. Program 2 is mapped to memory address 2. Then what about process 3, where all the space in memory is full? Well, that's where the process will stack, because without virtual memory, a program will crash if it tries to use memory RAM that it has. Now we look at the picture on the right where an operating system that uses virtual memory. When there is a process running, it will be sent to the map. Then the map will map a process into memory flexibly or randomly. When the memory is full, the map will look for space to process a process like a hard disk. With virtual memory, mapping gives us the flexibility to use RAM. That's all the explanation for me. Thank you.